Okay, so we are going to talk about memory today. One of the most important area in forensic because a lot of things get stored to memory, including your credential, application processes. So you're going to see some of that when you do the lab today. When you deal with malware, you're going to see a lot of the processes get loaded to RAM, along with um, along with a lot of information like access, resources, and so on. So some of the things that we want to touch on RAM is that RAM needs power. It's volatile, so it needs power to be able to retain information. So when you're doing a live analysis, you want to capture the RAM. Now, when you're doing the lab today, those are images specifically made from RAM. They are normally use a different type of file extension, and we'll touch on that. So RAM contain a lot of state-based information about your system. If you have running applications or programs on the computer and if you're investigating the type of processes or application, it's really good to evaluate RAM. We touch a lot on like drives and be able to do file card from it. And so what we can do is we can create a snapshot of your memory storage, which is a little different than what you see as a normal system image. And then we would be able to analyze it. So we want to capture whatever that's running live and then use that capture, that snapshot to do the analysis. Now, after you do that, then you can shut down the system, because if you shut down the system before you do the snapshot, what will happen is you're going to lose all your information, all the data that you need to acquire. So let's go through and answer some questions. What type of information can be found from RAM when conducting digital forensic investigation? You can obtain current state of your system before shutting down. So everything that's currently running, if you have services, right, like even connectivity, all of that is going to be stored on RAM. Information about running programs, legitimate processes, and if you're looking at Windows PC, Executor will have a group of processes for the application to load and run, right? And then some of those applications would have services like connectivity to the internet. It might use specific protocol. And then if you have running malware processes, which is what you see today with our lab. So malware tends to have a lot of processes that will occupy resources. So you will see the processes for the malware, and that can be obtained from RAM. Now, some malware specifically target RAM, but not all malware would permanently store on RAM. You do see some rootkit or some of the more advanced malware that it permanently stay or it find a location on RAM and be able to do that, but all malware processes get loaded to RAM. That's how the OS is able to control the processes in queue or running processes. Information related to network connectivity. So if you have, like I talked to my CIS27A students, and some of you are in that class, right? Your connection table, your ARP, your ARP table, the system that you are connecting to from your system. So it would have the information in RAM. And then if you are sharing files with other systems, so if let's say I right click the folder and I would choose to share that folder with other individuals. So if you have a peer-to-peer file sharing component on your system, it would store that information. And sometimes it would also show link of attackers' host. So in the case that if it is a server and if you have an attacker targeting that server, right, direct connection to that system, would also be stored on RAM. So in the case if you're doing incident response investigation, this is also very helpful information. But a lot of times we do forensic after the fact, right after the incident. But if you're doing it while, remember, right, you want to keep the system on in order to do that. And then you have user activity and actions on the systems. So you would see that, then that relates to like events and things like that, that is stored. And you would have passwords, it could be files, clipboard text, very important, right? When people copy paste, the copy component, so when you select copy, that gets put into RAM and it would go to that address to be able to pull the information so that way you can paste. So the user clipboard text information is there. And ultimately, for some of us, we want to be able to find encryption keys. Now, if the system has shut down, right, you will have to be able to reboot the system and be able to capture the snapshot of the RAM while it's running. But if you have a working system that is running, you want to take a snapshot before it shuts down. Okay, but sometimes they shut it down just to flush the RAM information. And sometimes it would retain the information, right? Because dynamic RAM, a lot of times you see that it's actually writing over the location, so you don't necessarily, so when it loses power, yeah, you're gonna have information loss. But when you turn the system on, it might restart the service and the processes. So you will be able to, or reload the web page, for example, right? So you will be able to revert some of the information or obtain some of the information when that service gets reset. Okay, for question 2 is ask you, explain why a forensic investigator should avoid disconnecting system power in an investigation. We know that the data is stored on RAM, which is considered volatile. So when we say volatile, that will be, it requires power in order to maintain the data. Where your hard drive and your solid state drive, it is non-volatile. So the data gets retained once the power is removed. So we lose volatile data when the computer is no longer powered on. So if you shut it down, you will lose information. Okay, so where can you find this information? That will be on page 1, that would address the majority of the question 1. It had more details about attacks and different things. And then RAM is temporary store with the working data on your computer. So the type of RAM that you would see, and I think some of you have taken classes that address hardware. So you have SRAM, which is considered faster and more efficient. This is mostly used within your processor. So when you have cache for processor, right, that is a temporary location where the processor can put information and be able to retrieve, and that uses SRAM. Okay, that's static RAM. And this type of RAM is a little bit more expensive. So if you have a higher cache size, it's able to actually just store more processes in queue, store more information, more data, so that way the processor can fetch it and be able to load it. Then you have dynamic RAM, which is your DRAM. This is what you see with your regular DDR, right? So right now, I think we're at DDR5. So this is what you see as a memory chip that's installed into your PC component. Now, even on a Mac OS, on an Apple systems or Android system, you always have internal storage. And internal storage is now considered either, if you buy a device, right, like a smartphone, you have internal storage that's equipped. In a regular computer, you can upgrade and add additional memory chip, but before Apple used to allow you to do that, but now they don't anymore, right? Decades ago, you were able to upgrade. I think they passed a bill that you can maintain your systems, but if you want to be able to upgrade your hardware, you would have to reach out to Apple stores and be able to get the advice on what kind of hardware that you need. Anyway, for the chip, it is DRAM is a lot cheaper. Now the speed of your RAM is really depends on the type that you buy, right? Normally for the PC, it would say PC and a number like 6200. That will be the clock rate for the actual chip. Now the motherboard is only going to be able to access it based on the motherboard speed. So even if you have a faster RAM chip, and if your motherboard bus path is slower, right, it's still compatible, but it's only going to run, it's only going to read and write as fast as the motherboard is able to provide. It's kind of like, you know, if you have a road that you can drive 50 miles per hour, even if you have a sport car that can go up to 160 miles per hour, you cannot drive it faster than that, right? So even on some of the chips, and then you have different compatibility requirement. So DDR, which is part of DRAM, and that's dynamic RAM, is a more common, and that's what you see in a lot of the PC systems. Okay. So we talked about how we shouldn't turn it off. So the two types of RAM that you commonly see, SRAM is in CPU, right? And then DRAM is, dynamic RAM is the RAM card that you install. Okay, so this is a crucial, this is old, this is like 8 gig DDR4, right? And you often see that it is, so I'll pass this over. Some of the spare part. So if you haven't touched RAM before, now in the laptop system, right, or some of the more compact system, your chip is going to be half of the size, right? It's going to be a lot shorter, and those are called SODIMM, right? So these are dual inline memory module. It reads in parallel, so you always going to have two cards installed in the system, right? You can put one, but it's not ideal. So it's going to write across dynamically. So basically, it's just going to grab addresses across the two chips, two memory sticks to be able to write. And you just simply align the pin, the gold pin to the slots. Now on the sticker, you would see that it would tell you the type of RAM and the speed, right? And Crucial website is pretty good. It, you know, you can go to their website, you can look at the type of RAM that you need or the upgrade that you need. So most memory website would be able to provide you that. So now DDR4 is dated. I think right now we're at what, DDR5, which is going to be faster than DDR4. So when you're looking at a DDR4, right, it's actually an upgrade from a DDR3. So it's just going to give you a little bit faster speed. Now this stick is 8 gigabytes. So if I want 16 gigabyte, I would have to have two sticks installed in my system. Now your OS, your Windows PC only needs half of the size. So it needs about 4 gigabytes, 3.96 in order to load the OS and all the services. So if you only have 8 gig on your computer, right, the leftover 4 gig is mostly used for other applications like Microsoft Office, right, or other services, as you know, that RAM is required for things. So With that RAM, the system will not run, and because it is a temporary location for a lot of things, especially the applications that you have. Okay, so if you want to take a look at it, I'll leave it up here. Okay, so what type of memory address is used for memory dump? And you often hear the term memory dump, right? When you are analyzing RAM or working with RAM. What type of memory addresses is used for the system processes? So you have two type of addresses. Physical addresses are used for memory dump, and you would see something like this, right? So when you get in Windows, when you get blue screen of death, right, usually that's a buffer issue. So when it's crashing and it tells you the blue screen, and it will tell you some type of address, right? And the error that's related to the address. So that means that it's not able to retrieve or store some kind of instructions into that area. And that causes the OS to have interruption because the system is not able to, continue with a certain service or load certain things. So you often see that it's going to use hexadecimal value, and it will start with an O, and the X indicates that it is an address location and would have a number like this. Okay. Now, the virtual addresses are used for system processes. In dynamic RAM, it just grabs the things that are available as fast as possible. So you don't really have to have a certain sequence in the addresses, but normally there would be a group of addresses being available. It's kind of like how you go into like a hotel, you're gonna have all the consecutive rooms that might be available if there's no one checking in, right? And so when they check you in, they might give you a room in the middle of the hotel, and then the next person a room on a different floor or in the top level of the hotel. So the system does that. It actually just grabs the addresses as it goes. So now the system processes that would pertain to your OSs and your applications. So software level, when you write or develop your program, it really pertains to the functionality of your program, your functions, how it loads into your system processes like this, right? And now in the operating system, there's two different level. You got the OS level that where the system has access for specific things. And then you would have a user related level where you would have processes that it's related to user control. So just keep in mind that these virtual addresses, right, they don't actually tie to a physical address. It's just a group of addresses that the on a logical level it creates that to be able to queue your processes. Where the physical address is actually permanent address that is created for that memory module to be able to be used for memory dump. Okay. So those are the two type of addresses that you see. For memory dump, you would require the physical address, and for the system processes, it will be virtual addresses. Okay, so in Unit 7, it really talks about how RAM can be integrated in the system, the type of RAM, your physical address, and the virtual address information. You can find that on page 2. Now, above it, you would see that for a 32-bit Windows OS, right, the limitation is going to be 4 GB of RAM, while if you have 64-bit OS, right, which is what we're currently using with Windows after Windows 7. So from Windows XP moving forward, what you see is we have upgraded, right, because we have the processor that's able to handle higher bit size for your operating system. So if you're using 64-bit Windows OS, you have up to 128 GB of RAM. You don't normally see that in the consumer PC. You might see that in a server environment where you would have motherboard that's capable of handling lots of RAM, right? Because the server requires that to be able to fulfill requests. So when you're looking at a server system like a web server, if you have concentrated requests like Google or YouTube, right? You need to be able to diverse that into multiple servers, lots and lots of servers, and each of the servers should have lots of RAM. So the more RAM you have, right? The performance level is your request is gonna be fulfilled because the request comes in, it's going to store on RAM and it uses that in that location to be able to find what kind of request information that it needs and it will respond. So when we're looking at denial of service attack, right, the limit you have in RAM is the higher chance that you have in coming down in denial of service attack. So RAM plays a really important key in the infrastructure. So what you see is if you're using a newer OS, right, you can have up to 128 gigabyte. But the OS itself, it's only going to require like, you know, about 4 gig for the bare bone to actually work. Okay. So to execute the code, as you know that there are tasks that the processor requires, right? Where it stores to your cache and then it goes and it fetches the information, and that's how it's going to be able to queue the processes. So each process gets an ID, an identification for the type of execution. And so it uses an identifier, and that identifier is related or linked to an address location on memory. So that way it's able to retrieve it and execute. Now for the operating system itself, right? I talk about how you have different level. So in operating system, you have the privilege separation where you have user mode and system mode. And I think I touched a little bit on this with this before. So now on the kernel mode, we as user don't really have that kind of level. So kernel is a layer that is between your hardware and your software, right? It is a way that software can pass instruction down to the hardware level. So we would be able to have a fully trusted mode in the kernel mode, okay? Now, for the user application, we access it at what they call an untrusted mode, which is the user mode. So in the user mode, we can execute command and we can run things. So when you click things, right, your system execute command, and that is an untrusted mode. But the system mode or the kernel mode is fully trusted, right? So what you see is that some of the malware take advantage of this and it would access resource at a more trusted mode, so that way you cannot intervene or there cannot be changes, right? So what you see is on your operating system kernel, the application must request access so that way it can execute the task in the application from an untrusted mode. So when you install application like Chrome and when you run it as an exe in Windows PC, what you see is the operating system looked at that application as an untrusted source, right? And it needs to have the request. So Chrome would have requests like access the network adapter in order to send signals so that way your browser has connection, right? So that's one of the process. So it would require that particular instance to be loaded into the processor as a request for the execution. Okay, so now the operating system manage all the processes and it would put all of this into RAM. Okay, the way Linux is designed for OS, Windows, right? Different operating system version and releases, but all operating systems require RAM for process execution. So in Linux, if you look up your P list, which is your process list, it would give you all the identification information for each of the process for your application. and all the related process with your OS, right? And where does it retrieve it? It retrieves it from RAM. Okay, any question regarding OS accessing RAM? I think if some of you take CIS21 or operating system classic, dive a little deeper in how OS is designed. Okay, so it talks about this here, and let's talk about threads. Okay, so each process can have multiple threads, and it is just basic unit for your system resources, such as CPU core. You would see that depending on the processor, if you're looking at AMD compared to Intel, the way it's designed to handle threads is a little bit different, right? Now some applications, it is written to capitalize on multi-threads, right? So when I teach advanced Python, I talk about that. What it is that you can have things that are executing in together, right? So it can multitask at the same time. So what we can do is we can capitalize on your CPU, right? Let's say I have 16 core. I can capitalize on that and get each core to do different things, right? Each core to handle a specific task for the process. So what you see is that this is really pertaining to your CPU resources. And when we analyze the processes, when we're looking at that, we just need to make sure that we identify the location of memory that would have the information about the process, because each process, when it gets fetched and loaded, it actually has a log of it. Your system keeps track of which process is in queue, which process get executed, when it gets done, right? And so it will help you identify the information for things. So why is this important in forensic? Like I said, outside of malware, we would see other things like when you're looking at the user using the application, not just outside of the application. When we look at RAM, it actually has the process information for that application. And each of the process would have information like identification and timestamp related to it. So the software is the forensic software is gonna pull, right? It's gonna pull the timestamp information from the memory location when you create that snapshot. Okay, so what is really in RAM, right? We talked about processes, we talked about user information, things like configuration information, your settings, your system settings, the state of your system, connectivity, right? We talked about that. So your configuration is stored there. Issue command. So when you type in a command, right, like ls in Linux to list, right, that command is stored in RAM because it has to execute, right, whatever the command that is. Now, at the graphical user interface level, when you click on a button, a menu, using resources on the graphical user interface, your OS convert all of that into commands, right? So I can open something, I can view something using commands, or I can open and view something using, prompt or windows with the OS. So everything translated back to the commands, and RAM stores that. Okay, we talked about passwords, unencrypted data, IP addresses. Some of you saw this in CIS40A when you look at the ARP table, or when you use PowerShell to look at connection, whether it's listening or it's established. Internet history, even chat conversation. So if you're looking at mobile devices, right, the internal storage keeps this. So when you run forensic software on mobile devices, you're gonna see that it might retrieve a bunch of things that they deleted long ago, right? Even images, chat, email, right? Because it's able to pull that from the internal memory. Now, a lot of the manufacturer actually sell you the device scaling to the cost of memory, right? So you would see emails and then ultimately malware. Okay, so let's talk about 5. So what should an investigator examine when analyzing memory dumps? The processes, we talked about the processes that were being executed at the time of capture. What is currently running, right? The data that was being stored within RAM, and some data will be there, but not in your drives. Because all applications access some form of data, right? Some of you learned this in programming. We use application to be able to have data input and data output. That's ultimately, and that's the goal for software. So what you see is that some data is temporary, right? Like I teach C++ right now to cover for someone, and I tell my student, when you create a variable, it actually puts that into memory. But if you want your data to be more permanent, then we need to export that data, port that data into your database, right? Where it's stored permanently. So sometimes you would have applications that have temporary data, and then once it finished that task, right? And this is the return 0 in C or C++, right? It flushes it and it gives that storage back so that way the system can use it for other things. So some data is temporary, you can capture that in RAM, but not in the drive. So if you try to carve it as a file in the drive, it won't come up, okay? But if you run the RAM snapshot and do a to look at the RAM, you are actually gonna see it. Okay, and then it gives you your process timestamp, which is what we talked about, starting addresses and the code for the processes. Okay. Now you have systems sometimes can go into hibernation, right? That's it. It's set to do that. You see this with Windows. So sometimes computer don't get used for a period of time and it would hibernate to save power. So the way that it works is that it takes the current state of the system, because it is a state machine, and it puts it on RAM, right? It creates a file called hyperfill.sys. This file is used for retrieval purposes. So if I have tabs on my browsers that are open, connectivity to the internet, things like that don't get timeout, right? Like I loaded a web page and I was on it and I walked away from my computer for multiple hours, and my computer is set to hibernate to save power, right? So what happens is when, in the new Windows, you put it to sleep. So it would allow the system to power down, and it would use this file that is stored onto memory to be able to retrieve when you power it back on. So when I press the power button, after I want it to wake up, it's going to access this file, which is in RAM, and then be able to pull that. Okay. Now, so what you can find with this is you can find the state of the system before it goes to sleep or hibernation. Okay. So if they have things are running, things are loading, services that's happening in the back or with the application, you would see that. Okay, so hibernation file, you can find that on page 3 at the beginning. And then you also have page file. So page file is for data that is used by RAM. And this page file is specifically related to virtual memory file. So it is a little bit different compared to, so this is for hibernation, right? This is to retrieve data for the storage use. And instead of using the capacity of your memory, it creates this file to capitalize on your primary storage, which is your drive, to be able to use it as memory storage. Or virtual storage. So page file usually pertains to virtual storage. And then when you see a crash dump, you would see a memory.dmp. So this particular file is only pertain to system crashing, OS crashing. So when you get blue screen of death, this is the file to look at. Okay, your memory dump. You get that error with the memory address, right? The little sad face now with Windows. So it would, so when that happens, this file is created, right? It would have, it creates a crash dump, and it would store the state of your system at the time of the crash. So, and then, you know, your Windows OS will tell you, do you want to do a memory check? Because of memory, that's how you have that crash. So you would run the memory check, and then it's going to restart your system. But how does it know the state of your system? Well, because of the dump file. Okay, so in the case that if you are troubleshooting or you're looking at a server that crashed, this is helpful. You want to be able to evaluate, like, why is it crashing? A lot of the times it has to do with, like, either RAM is not working accordingly or it's running out of RAM. Okay. So this is used to revert your system to the state as before it crashed, right? So when it crashed, it saves this information to the memory dump file. So you have different type of memory dump. You have a complete memory dump where the data inside your physical memory, right, is not able to access, or something happens to it, you have issues. The data cannot be stored, it can't exceed the amount of memory that you have, something that's pertaining to your physical memory. So not too common. And then you have the kernel memory dump, which is related to your OS, and that will be the pages for the kernel mode, which is the protect mode. And then you have small dump files. So this contain running processes, drivers at the time of the crash. So outside of the memory.bmp, you also have the dump files where it tells you. Now in your registry for Windows, you can also go to this hide for your registry, and you should be able to also find crash dump information, because Microsoft designs it so that way it can, because it pertains to the OS and the hardware, what you see is that it keeps a record of it. Okay, so dump files cannot just be read and open, right? When you have it, you need to be able to use a tool to be able to read it. So I put down some information, a website for you to look at. It is a third-party tool that you use to be able to look at memory dump. And there are open source tools that are available, and you can find those, but you can't just open them up in a regular Windows environment or your OS. Okay, any question regarding memory dump or OS? Okay, so let me move this to the next page. So number 7, what is stored on your page file.sys? This is your program data when it exceeds the capacity of your physical memory. Virtual memory is used to store pages on the drive in the OS root volume. So technically it's using your hard drive or your solid state drive as a memory storage. And that would pertain to a page file. You can also change your virtual memory sizes through your operating system. And that can be done through your system settings in Windows environment. But when you have low memory, like let's say I only have 8 GB of RAM and I want to, my application requires more, so it would put the virtual memory as added to the existing RAM so that way it can load. Okay, so you can use resources from your drive as RAM through pagefile.sys. Okay, and then we talked about memory dump. You have complete memory dump, kernel memory dump, and small dump files. Those are the three that you see. The least common one is a complete memory dump. And this could be like bad RAM stick, old RAM stick, or not enough, right? Kernel memory dump that contain pages for your kernel mode data, and your small dump files contain information for running processes, drivers at the time of the crash. So all of this is related to crash information, right? Now, you might have users, like malicious users, that can cause, like they might run something or they put malware that can cause the crash. So then you have to do the forensic on why it was crashing, right? Okay, so in RAM analysis, what is the effect of using USB devices in system memory? When you plug in a USB, it will load the driver into the memory. So as a forensic investigator, I have to put in a USB drive so that way I can capture the live systems, right? So because I wanted to take a snapshot of the memory as it is running. So just keep in mind that your driver will load, because all your devices that plug in, and USB is plug and play, any plug and play devices will load to memory. System may load the USB device driver into the registry if you're using Windows environment. So those are the two effects that you see with USB. So just keep that in mind. And then if you do this for like a court case, just make sure that you document it, right? That you have used an external USB drive to be able to capture the image, and the possible effects for that is that your USB drive actually gets loaded into memory snapshot, right? Which doesn't usually get evaluated. So it will contain that information and the driver. And with this, it allows you to have auto play for the container. Any question? Okay. All right. For the next question, you can refer to page 4. It talks about scientific work group on digital evidence, your SWGDE. And this is the resource is going to give you some information about application that will be used, tools that's associated with files for data overwrite. And we talked about your USB devices, right? And the application that is used for data in memory when you're doing the collection of your artifacts. So for number 10, it says, based on scientific work group on digital evidence, what should you consider when using applications to analyze volatile data RAM? So if you're using a tool, right, like Volatility3, you have to consider these things. That the tool that you use might write over some of the data on the actual memory. Okay, because it's loading to RAM. The larger tool and associated files are, so the larger it is, the more data that requires to put on RAM. So if you're using a very large tool, right, it's gonna require more RAM storage, and that might write over existing data that's on there. So the data is lost. Okay, so that's the risk behind using memory analysis tool. It requires RAM access, and sometimes it writes over the data that's there. So if you start the process with analyzing RAM, what do you really need? You need to have a device to capture your snapshot. Normally, we would use a USB device. You need to have access to the system, so some kind of authentication login and administrator or root privilege. So you have to have the highest privilege, and through that you would have the access, and you would need to capture the device. So if you're handing a running system and they wanted to tell, they ask you to see what is on it, right? You need to have an external USB drive to be able to capture it. You need to have the tool, right? Memory. So memory snapshot tools don't always get included in forensic toolkit. Some forensic toolkit will have it, but a lot of the times what you see is they are individual tools that you would use. So the software, and then you need to have the access and the privilege or privilege access. So those are the things that you would need. So what kind of tool do I need then, right? What kind of software do I need? Dumpit is one of the tool that is specifically used for memory. If you use the FTK suite, right, there is a feature where it is only for memory, so it's FTK memory capture. Later on, you are gonna use bulk extractor in your lab, so bulk extractor is Windows friendly, so you can use bulk extractor for that. Wallets is also a tool specifically for Windows, and volatility, I think at version 3, that is a Python tool that is open source, and you can find this via GitHub, or you can run it on Linux system. So volatility. And so when you use these tool, what you do is you are going to capture the memory snapshot files. Normally they come in as vmem, or some kind of file extension that pertain to, the image for just RAM. It is not a full system image. The image for just RAM, it's gonna pull the process information, all the information that's stored at the addresses on your RAM. So it is specifically focused on that. Compared to what you've seen when we were looking at like volume and partitions on the drive. So drives are a little bit different, right? But with these, they also pull from address location, and a lot of them are command line only. Okay, so today you're going to use the tool. Hopefully you don't have any challenges, because open source tool is always questionable. And then some of them will have graphical user interface where it shows you the address location, but a lot of the tools are going to be CLI. Okay, so I'll put 11 and 12 to the next page. And I think that's it. Oh, actually, let's put it back. It's actually a short chapter. But I want to emphasize that you can go through and you can look through your notes again. I did put some details on specific tool, on how to use Dumpit, where can you get it. So the website is there. It is developed by Moonsul. So Moonsul, and then you can, And I took some screenshot. There are a couple tutorial videos that are out there. I think also you can see if there are resources on their website with their documentation. So it would look something like this. Like I mentioned, right? It is all manually. And then your FTK Imager Lite, by Access Data, it would look something like this. And I put down some step-by-step for you there. So capturing memory snapshots are slightly different than creating images, like what you've done with your USB or your drives, right? So that's slightly different. And you notice that the file name, usually it's mem.mem or something mem. And then bulk extractor is by Digital Corpora. And they make, I believe they make decent software. So you will see later on, we are going to use bulk extractor, one of my favorites. And it similar to what you see with autopsy, it's going to give you the pane, and then you can select the folder or the files that you want to look at. So it's going to try to pull as much as it can to be able to give you the view. So it looks something like this, very similar to what you see with autopsy. So we will use bulk extraction to pull like email and other things. So it's gonna look something like that. And then volatility and Volix. So you can go to volatilityfoundation.org. The only thing with volatility is sometimes these tools are specifically aimed for certain purpose, and then you just gotta make sure that you have the right packages, or if there is a requirement for the tools, you gotta make sure. When you're using Linux, always update your Linux before you install any of these tools, because if you lack updates, your tools will not work, okay? Because they develop to really run with the current OS updates. And then when you have a framework, usually that would have additional features or tool sets. So you can go through and you can do them. These wallets and volatility, they are mostly used for malware analysis in memory, right? So if you are doing, if you work for a company and you need to be able to analyze like a specific malware, these are the things to look at for forensic. So we're gonna analyze stucknets today. There was one semester that like all the malware just kind of disappeared from different websites, and I had to scramble. But I had saved and backed up some of the things. So, there are different type of memory snapshot with malware that you can use to practice. So we will use some of that today in Cali. And now also sometimes you would see some features that kind of, they stop supporting a certain feature. So sometimes some scan don't work anymore because that module stopped being updated, right? So you will see in some cases, some of the stuff might not continue to work over time. Okay, so Volix will look something like this. And you are going to see process ID or SID, right? You're going to see some of that as you look through the output for your analysis program. Any questions? So we don't really need these drives today. I only put it here in case if some of you might need it, and I forgot that we're doing memory today. But we can take a short break and then get some snacks, restroom or water, and then maybe I'll take attendance before you go to break. Then when you come back, you can start your lab. You shouldn't have to take too long to get through the lab. If you have challenges, because I never know what, sometimes they don't update certain packages, so. But I will walk you through the lab using Kali, so make sure you download extract, Kali using 7-zip. And then we will be able to work on our lab, and I'll be here until the end of class, so